On this question, it says at a local university, GPAs were compared for men and women to see if women have a higher average GPA. What do you think? Do you think women have a higher GPA at our college? My guess would be almost for sure yes. It's been my experience. The women are usually doing better than the men. Don't want to discourage you men. I have some men that are doing great, but in general, the women GPAs are higher. All right. Anyway, let's see if there's a strong, in this little made up case, if there's strong statistical evidence for that or not. So 55 men were surveyed. The average GPA for the men was 2.32 and standard deviation 0.72. 50 women were surveyed. The average GPA for these women was 2.95, so that's higher. Standard deviation 0.65. So it's already, I'm thinking, yeah, it looks like there's probably evidence there. Okay. Give a 95% confidence interval for the true average difference GPAs of men minus women. See what it says right there? It's kind of important. Right there. So men minus women. Okay, so that means there's two groups. It's mu1 minus mu2, men minus women. And why mu? Because average. P's are for percentage. We don't have percentages here. We have averages. Average, right? Average GPA, grade point average. So, and mu, mu, this is mu1 and mu2. And mu that's a Greek M, even though it looks like a U, it's a Greek M called mu for mean. It stands for mean or average. So we use it whenever you're talking averages. We're talking averages and we're talking about the difference, the minus, the difference between men and women's average scores. So average GPAs. All right. So they want us to do a 95% confidence interval. So where are we going to go? Well, let's go. Let me look at the notes. I'm taking to the notes here. Here we go. It's not proportions. And so it's two independent means or two dependent samples with data. Well, first off, it's not data. So it must be two independent means, and that's what it is. Men and women, just two separate independent groups. They're not matched in pairs. They're independent. We're going to go to the online calculator, two independent samples with data if you have a data list, or with statistics if you have no data list. We have no data list, right? Back to the question here. See, there's no data. There's not like here's data. Here's a different problem. See, that's a list of data on a different problem. We don't have that here. We just have, you think, well, this data? Well, these are called statistics. Right. We don't have it was 55 men. We don't have the actual 55 men's scores. That would be like a big old box like this, men and be their actual scores, and women, that's a different problem. We don't have the actual data. We don't know what the 55 men actually score. We just know the average for them and the standard deviation. And the women, we don't have the 50 women. We just know the average standard deviation. We just have statistics about them. So we are going to then back to the note, this unit 4 notes. We two independent means here. Okay, there we go. Two independent means. We are going to do online calculator, two independent samples, not with data, but with statistics. So two independent samples with statistics. All right. Two independent samples with statistics. Yeah. Right. Oops, I got off a little bit here. Okay. Anyway, there we go. Two independent samples. Let me erase that. That's what we're doing. So let's do it. So you write that somewhere. In fact, I still like there's room. Okay. So there we go. So now I'm gonna go right. Kind of run out of room here. Two independent. With statistics. That's the calculator we're going to. All right, two independent samples with statistics because we don't have data. So let me show you the online calculator. It's not it. Here it is. So two independent samples with statistics. That's number 18. Two independent samples with statistics, number 18. And as it pops up, there's what they want from us. Sample size, sample mean, standard deviation, first and second. So sample size, mean, and standard deviation. Sample size, mean, and standard deviation. So we go, okay. So sample size, mean, and standard deviation for the first group and the second. Okay, so what's the size of the first group? 55 men. Oh, and who is the first group? First group is men. Second group is women. How do we know? It's just the order they were in the problem. Men and women. And right here it says men minus women. So men comes first. So men, what's the size of the men group? 55 men. And what was their average GPA? 2.32. What's their mean, their average? Standard deviation, 0.72. And 50 women. And GPA was 2.95. That looks higher. And standard deviation, 0.65. I mean, that is higher. 0.65. Okay, there's the data that we're going to put into the calculator. And then we're going to choose confidence level. What they say for us? Oh, 95%. So make that a decimal point 95. Let's go back and do it. 2.32, 0.72, 2.32, 0.72. So 2.32, 0.72, and it was 55 men and 50 women, I think. And 2.72, 55, 50, okay. And 2.95, 0.65, 2.95, 0.65, 2.95, 0.65, 2.95, and then 0.65. Console was 0.95. And there's everything. Calculate. I don't care about the T and the P. I'm just looking at lower bound, upper bound. There they are. So again, I put in the data. 0.95 for the confidence level and lower bound, upper bound. Negative 0.895, negative 0.3648. Let's see if that's right. Oh, it's not here that way. Yeah, okay, I'm gonna have to show you how to do that. That's a little tricky. Okay, yeah, let me grab those numbers and put them here for us, and I'll show you exactly what we're gonna do with that. One more time. So it's negative 0.89516. Negative 0.89516. So negative 0.89516. And what was the other number? It was negative 0.36483. 36483. Negative 0.36483. That was the lower bound and the upper bound, right? Those were the two numbers from the calculator. Now, that's not our answers yet. How are we getting answers? Well, this is the whole change it because what they want is they want the middle plus or minus the jump, right? They want it in that other format. We did that in the last chapter. Remember how we do that? How do you find the number in the middle? What's the middle of these two numbers? You add them and divide by 2. Now, the quick way, though, is you just go to the calculator. It's already there. Let me show you. Go back here. In fact, if you go down to the very bottom, here's, see on the very bottom there, that a negative 0.630? You see that? Wait, where is it? Is it anywhere else? No. It's right there. Yeah, let me show that to you. Here, let me make it a little bigger. I'm going to bring it over here and I'm going to show it to you and I'm going to write on it for you. Yeah. Let me just focus on that last part. That's all we need right there. So if you look at the very bottom of that calculator, well, maybe that's confusing for you. Yeah, here, let me just put the whole thing. So if you go to the calculator, so this was the online calculator. Let me write it up here. This is the online calculator. If you look right there, you see there's the number in the middle. See, there's our two numbers, the negative 0.895, the negative 0.33. It tells you the number in the middle. There's the middle number. It just gives it to you. Negative 0.63. Oh, you put a 0 in front if you want. Negative 0.630. That's the middle number. Is that right? Negative 0.6 just wants two to say two decimals. So yeah, there's that. That's good. And then you got to find the jump. How do we do the jump? Well, The jump, I don't know if you remember, the jump is how far from this middle back or forward. That's what we mean by the jump. The jump is how far from the middle up or down. So then you can take the jump will equal the middle number minus the low number. Now, careful with your signs here. The middle number is, as we say right here, negative 0.630 minus, subtract, what's the low number? It also is negative 0.895. See the double negative here? Do you remember what double negative does? It becomes adding. Remember that from earlier math classes? See, you see what I'm doing here? So the jump, again, the jump is how far from the middle number back to the low number or up to the high number, right? This is the lower bound number. This is the upper bound number. Calculator gave them to us right here, and just brings it down there and brings it down there, right? And then it shows us the number in the middle. And then the jump is how far from the middle back or up. So you can take the middle number minus low, but watch out. The middle number is negative, the low number is negative, and then there's an extra minus in between, right? See how the middle number is negative, the low number is negative. Here's the low number, here's the middle number. And then you've also got that minus sign in between. So double negative becomes positive when you put that into your calculator. So when you put that into your calculator, it's going to come out, it's going to equal what? 0.265 positive 0.265. That is the jump. Is that what we got up here? Oh, and then they want us to round it to 2 decimal places. So it's 0.27. Round to 2 decimals, 0.27. So there's the middle number. There's the jump number. Yeah, so that's how we get these. There's the middle number. There's the jump number. So how did we do that again? So we took the numbers they gave us right here, put them into the 2 independent samples with statistics calculator, online calculator, put in confidence level 0.95. It gave us the lower bound, upper, it gave us this. Here's what came out of the calculator, lower bound, upper bound. And then down here's a beautiful graph. It tells us the middle number because they want us to give it in the form of middle number plus or minus jump. So we go, okay, well, the middle number's just right here. And then the jump is always how far from the middle down or up. So take the middle minus the low, middle minus low, subtract those, but watch out for the double negative there. Comes positive. Do that in your calculator. You get 0.265, rounds to 0.27, 2 decimal places. So there we go. So we're basically saying here's the 95% confidence interval from that middle plus or minus that jump. Now, according to your confidence interval, which one is the right conclusion? You see it down here. How did we arrive at that conclusion? How do we know what it means? Well, this is where we again have to go back to the meaning of a confidence interval. Let's see if I can find it here. Where is it? It's not there. Oh, I don't have it. Okay, so all right. Let me just put it right in here for you. I think I can get it. So from the notes, the meaning of a confidence interval. That one, no. Is it that one? Nope. It's gonna take me a second here. That one? No, it's that one. Yes, got it. All right. So this is from the notes right here. Okay, so let me easier to see. All right. So there we go. So this right here is the Unit 4 notes. And if you go right down here to number 4, meaning of a confidence interval, it basically tells you what if you have 2 negative, both negative, you end up saying mu1's less than mu2. You have 2 negative. If you have 2 positive, all positive, you end up saying mu1's greater than mu2. If you have some negative, some positive, you end up saying they're different, might be same. It's inconclusive. So there's the 3 options and how we figure out what the confidence interval means. So let's go back up. What was our confidence? Now, notice it's showing parentheses. You see that? So what was our parenthesis answer? What's the first answer we got from the parentheses? It would be these two numbers, the lower bound, upper bound. Those are the two numbers in the parentheses. So I got negative 0.895 and negative 0.385. Negative 0.895 and negative point something else. 3, I can't see them. Negative 0.895 and negative 0.365. Negative 0.3. Come on. This problem is going on and on. Negative 0.365. There we go. So notice it's negative and negative. Now I don't want you to confuse. You might say, "Whoa, no. I might look here." So no, don't look here. Remember, you look at the first answers you got from the confidence interval, which is, the lower bound. It's always about the lower bound, upper bound. Lower bound, what are they? They're both negative. They're both negative. So what does that mean if you get both negative? All negative, mu1's less than mu2. Mu1's less than mu2. First group is less than the second group. Who's the first group? I don't remember. I forgot what this problem is even about now. It's men and women, right? First group is men, second group is women. So the men are lower than the women. That's what the confidence interval tells us. Because it's negative, it's all negative. It tells us the first group is lower than the second. The men are less than the women. So the GPA for the men, lower than the GPA for women. We choose the lower one. Lower than the women. Why is that? Well, because that I showed you how to find it, but I want you to see it logically, not just, hey, step 1, step 2, step 3, monkey see, monkey do. But what does it mean? Why is it less? Well, because our answers are negative, you see. In other words, we're saying we are 95% confident. 95% confident that the real answer is somewhere between negative 0.895 and negative 0.365, right? Just look at the graph here. Yeah, how about this? We're saying we think it's between negative 0.895. Where's my? It's not working. There we go. Here and here, right? All these are negative numbers, right? Between negative 0.895 and negative, these are zero somewhere over here, right? This is negative from here to here. That's all negative territory. Positive numbers are over here. Negative numbers are on this side. Zeros must be about around there. So the point is, we are 95% sure that the real difference, you remember, we're always trying to figure out the real difference between all men, all women, whole world on whatever it is we're testing here, GPA at college, like all men, all women, based on the data we summarize. We're 95% sure that if we could do the difference in average GPA between all men, all women, and all colleges, it'd be somewhere between negative 0.895 and negative 0.365, which means it's going to be negative. The difference is negative. It's between two negative numbers. It's negative. Well, so what? So what it's negative? Well, if I told you I subtract two numbers, like 7 minus 10 comes out negative 3, that means the first number is smaller. How do you subtract two numbers and get a negative answer? Only when the first number is smaller. First number is smaller than second. Because we know we're 95% sure that the real difference between men and women, remember, this is the difference between men and women. That's what this problem was all about, as they said right here. Men minus women. We're 95% sure that the difference is negative. If it's negative, the first number must be smaller. If you subtract two things, get negative, first number is smaller, which means the men is less than the women. That is our conclusion. We're 95% sure that the men are this much lower. Their GPAs are between 0.89 and 0.36 lower than the average GPA for women. And so there we go. That was a hard one.